Hello and welcome. Every single day, you're surrounded by technology that's keeping patients safe and making healthcare work. I mean, from vital signs monitors to really complex AI, these machines are basically our partners in care. But have you ever just stopped and wondered how they actually think? Like, what is their native language? Let's dive in and find out.
Okay, so picture this. A monitor shows a patient's blood pressure, 111/70. Now to you and me, that's just two numbers, but to the machine, it sees something completely different. To that piece of hardware, our numbers are like a foreign language. So how on earth does it translate them into something it can actually understand and act on? Well, that's the big question we're going to unpack today.
And to really get to the bottom of this, we're going to lean on some fantastic material from Dr. Abdulkarim Iblasi's Nursing Informatics lectures. He does such a great job of making these complex ideas simple for healthcare professionals. And we're going to break down some of his key insights on how computers really see the world.
All right, let's start with the absolute basics. You could call it the machine's alphabet. And it turns out computers don't have 10 fingers like we do. Nope. They only really have two states, on or off. And you know what? That simple fact changes absolutely everything.
So here's where things get really different. We humans, we think in a decimal system. Base 10. We use 10 symbols, 0 through 9. But machines, they live in a binary or base 2 world. They only have two symbols to work with, 0 and 1. And everything, everything a computer does, is eventually boiled down to a long sequence of just those two digits. Now, this isn't just some abstract math idea. Binary is physical. A 1 literally means there's an electrical pulse in a circuit. It's on. And a 0 means there's no signal. The circuit is off. That's it. It is the simplest language you could possibly imagine, and it's the physical bedrock of every single digital device that we use.
So how does our blood pressure number, 111, actually get translated? Well, it's a really simple process called successive division by 2. You just keep dividing by 2 and writing down the remainder. So 111 divided by 2 is 55 with a remainder of 1. Then you take 55, divide by 2, you get 27, remainder 1. You just keep doing that all the way down until you can't divide anymore. And here's the magic trick. To get the final answer, the computer just grabs all those remainders we jotted down and reads them from the bottom to the top. So our everyday number, 111, to a computer is 110111. It's the exact same value, just spoken in the machine's native tongue.
Okay, so if binary is the alphabet, then we need some grammar, right? We need rules to actually form sentences and make decisions. This is where machine logic comes in, and believe me, it's way simpler than you probably think. Let's check it out.
Get this, computers make every single decision using just three basic operations, and, or, and not. That's the whole shebang. And is the strict one. Input A and input B have to both be true or 1 for the output to be 1. Or is a little more relaxed. If either input A or input B is a 1, then the output is 1. And not is the easiest one. It just flips the value. So not 1 becomes 0. That's the foundation of everything.
Now, let's bring this back to the clinic. For a patient to get their medication, a computer system can be programmed with a very simple rule. An appointment must exist, that's a 1, and a doctor's order must exist, that's another 1. If either of those conditions is a 0, the system stops. It won't proceed. That's the AND operator in action, making sure our workflows and patient safety rules are followed.
And this is the really mind-blowing part. Every single alert you hear from a vital signs monitor, every safety check inside an infusion pump, every complex decision is really just built from thousands or even millions of these super simple and, or, and not decisions all chained together. It's amazing how powerful that becomes.
All right, so we've got our alphabet, which is binary, and we have our grammar, which is logic. But how do we get from those tiny little building blocks to the incredible software we use every day, like an electronic health record? Well, it's all about building things up in layers.
See, humans don't write code in zeros and ones. It would be practically impossible. Instead, we work way up at the top layer, using what we call high-level languages like Python or Java. They look a little bit more like English. Then, special programs act as translators, taking our instructions down through a middle layer and then finally all the way down to the bottom, machine language. That's the raw binary code the computer's brain can actually execute.
And you see this every single day. That lowest level, machine language, that's what's running the guts of the hardware.
things like infusion pumps and ventilators. But the big, complex applications, your EHR, the scheduling software, that new mobile health app you're using, all of those are built using those much easier, high-level languages.
You know, Dr. Blasi has a brilliant analogy for this. He says to think of a programming language as a Google Translate for a robot. As a clinician, you don't need to speak in ones and zeros. You just use the software, and the system handles the translation for you, converting your clicks and commands into the binary instructions that the machine needs to do its job.
Okay, so let's take this one giant step further. We've covered traditional software, but what about the really cutting-edge stuff, like artificial intelligence? How does something like ChatGPT learn to understand and generate human language? It's pretty cool.
So the first step is actually fascinating. An AI doesn't see whole words like we do. It breaks our language down into these smaller pieces called tokens. So a single word like medication might get split into two tokens, medi and cation. This is so powerful because it lets the AI handle a huge vocabulary and even figure out parts of words it's never seen before, which makes it incredibly flexible.
So what is a generative AI really? At its core, it's a prediction engine. After it's been trained on just massive amounts of text, I mean a huge chunk of the internet, its only job is to look at a sequence of tokens and then calculate the most statistically probable next token. It's not thinking like we do. It's just an incredibly sophisticated pattern guesser, stringing words together one piece at a time based on what it's learned is most likely to come next.
And that brings us right back to our main point. Even something as mind-bendingly advanced as ChatGPT is built on the exact same fundamental principles we've been talking about. It's all about representing information in a numerical format, in this case tokens, and using complex math and logic to process it. It's just binary and logic, but applied at a truly staggering scale.
So why does any of this matter to you as a healthcare leader? It's a fair question. This isn't about you learning how to code, not at all. It's about learning how to communicate effectively with the most powerful tools you have.
Look at this slide. This is the practical payoff. A vague prompt like, help me manage staff, is going to get you a vague, pretty useless answer. But when you understand that the machine thinks in logic, you can give it a structured, specific prompt. You define a role, a task, constraints, a format, and all of a sudden you get a genuinely useful result. You're speaking its language.
And really, this is the ultimate takeaway. This knowledge isn't just some technical trivia. It's about strategic literacy. When you understand the fundamental logic of how this technology works, you are empowered to ask better questions, to design smarter workflows, and to lead your teams more effectively in a healthcare system that is digital first.
So I'll just leave you with this question to think about. Now that you've had a little peek behind the curtain and you understand the basic language of these machines, what new possibilities does that open up for you? What new, smarter, and more specific conversations will you start having with the technology in your organization? Thanks so much for watching.